Hello everyone! With the holiday season approaching, I decided to make this cute little game in which we are going to decorate a Christmas tree. In this video, I'm going to showcase to you the most common drag and drop behaviors, starting of course with simply dragging and dropping something, and then moving on to dragging something and snapping it to a point like we did here, and even replacing whatever was at that point if we add something new. On top of that, we are going to also take a look at putting things at predefined positions and even replacing or moving things away if we put them, let's say, on the same position as before, like in this case. Now, on top of that, I'm also going to showcase to you the architecture that this game is using because it's very simple and because it allows us to connect any kind of decoration to any kind of behavior that is defined by an area on this tree. So let us get started. Now I'm going to use this diagram in order to show you how the game is going to be laid out. The main thing that we need to understand is that all we want to do is to take a decoration and move it to a corresponding area. Now, how are we going to do that and why do we need so many components in order to do that? Now, first of all, this is a content manager. And this component is going to be responsible with generating multiple decorations of a certain type and basically just holds the information about these decorations for our drawer. Now, you might be wondering why I did not do this whole functionality directly into the drawer. Why did I have to make a new component? Well, I made a new component because I wanted to separate the responsibilities as much as possible. I want the drawer only to act like a drawer, to be pulled with the mouse or to be pushed back with the mouse, and that's basically it. And the content manager is going to manage the actual decorations and instantiate them and whatever. Having this in mind, the next part would be to simply group these drawers together, and grouping them together is simple because we just make a parent node. Now, these drawers are going to send a signal whenever these decorations have been dragged and dropped, and this signal is going to reach our main function. This main function, with the decoration in mind and the area that's the destination for our decoration, is going to call a function that will identify this area and will simply tell the area to add this new decoration to it, depending on whatever rules this area has. Now again, what's very important is that we want to have separate concerns between the area and the decoration. We do not want the decoration to do any fancy stuff, we want the decoration only to be dragged and dropped. And the area is the one who is going to decide what happens to our decoration once it is dropped. Now, let's see how we do this in practice. And let us start with the most simple thing, with a decoration. Now, a decoration is simply an area 2D which has a sprite and a collision shape. By the way, I named this Draggable because I felt like it's a more generic name which can be used in more cases, but you can call it whatever you want. Now, if I go into my script, you will see that I have already added some things to this script. Now, do not worry too much about the code that has already been written because I am going to cover it all anyway. I just didn't want to have you waste time watching me write this all by hand. Additionally, these parts which are crucial to the functionality are still going to be written by hand so that we can go over them step by step. Now, what other place to start if not at the ready function? You see, in the ready function, all we do is initialize some parameters for our draggable component. We initialize the texture to whatever texture it receives, an initial position, an initial scale, and also a spawn animation. Now, you might wonder why do we have an initial position here? Well, the main reason for this is just to tell the content manager where this has been spawned so that it can spawn another draggable once this is going to get destroyed. Now, of course, we could have had the content manager directly keep track of our positions in which we spawn elements, but the content manager already had pretty much code and this was pretty free. So even though it's not the responsibility of the draggable to announce the content manager that, hey, this is the position that I've been at, we are going to implement this part here. Now, with the scale, we just need the initial scale because we place some animations on spawn and on self-destruct, which set the scale to the initially set scale. Now, the first thing we should think about is what actually happens to our draggable if it's being dragged. So for that, I have an isDragging variable set here. So if our draggable is dragged, so if is dragging, what's going to happen? Well, we would like to have it follow our mouse. So in order to do that, we are simply going to say, okay, global position is going to equal to get global mouse position. Now if I save, and if I set this to true, if I run the scene, you will see that this indeed does follow the mouse position. Now, the way it follows it is not very smooth, so how could we do it better? Well, what we could do would be to linearly interpolate between the global position and the get global mouse position, so that instead of going from, let's say, 1 to 5, our position will go through 1, 2, 3, 4, and 5. Now, this is going to be pretty easy to implement because Godot already has a linear interpolation function. So I could simply write lerp, and you see this function simply returns a value between from and to with a given weight. If the weight is, for example, 0, it's going to return from, and if the weight is 1, it's going to return to, and if it's 0.5, it's going to return exactly the value at the middle of these two values. Now, how are we going to make our global position go from 1 to 3, 4, 5, as I said in the previous example, if this only returns a single value? Well, we can do that if we use the time as our weight. You see, the time always advances in our process, so it's going to get all our values. So what we can do is to go from the global position to the new position, which was get global mouse position, and we could advance by delta. So we could use the weight delta, if I write it properly. Okay. Now if I save, and is this still true? Yes. Then if I press F6, you'll see that it takes way more to reach my mouse position. Now, of course, I could make this a bit faster, and that's why I have a dragging speed here and multiply it by, let's say, 50. Now, if I press F6, you'll see that it still follows my mouse, but it does it in a much smoother way. Okay, now we know what happens when our draggable is being dragged. Now, the only thing that remains is to find out when the draggable is actually dragged. And what I would like to have is a decoration that is dragged whenever I click and hold with my mouse. So for that, I'm going to need an input event. And if I look at the draggable, if I go under node, you see that I have here under collision object 2D input event, which basically can check for any kind of event. So if the event is going to be click, which I have previously defined in my input maps here as a click event, I am going to set isDragging to true. Now let's set it back to false. And if event.isAction pressed of click, then we want to set isDragging to true. So if I press F6, you'll see that this no longer moves, but if I click, it starts following my mouse. Okay, but now it's sticky, it doesn't leave my mouse. How do I make it leave whenever I release? Well, a first thing you could think of would be to say, okay, in the same input event, I would just say else if actually, event.isAction released of click, then isDragging equals to false. And you might think that this is working because I'm dragging and now I'm releasing and you see that it works. But what if I'm dragging faster and I release before the draggable reaches the mouse position? So let's say I drag it like this. See? Now I'm no longer clicking because I released the mouse while it was not above my draggable. Let's try that again, so because now you know what to look for. So if I start dragging this, you see, I can release it because I was with the mouse here. But if I move very fast, my mouse is going to be above air and not above my draggable. So if I move fast, I released it, and now I'm really not holding my click, and this still follows me. So then we would want some way of checking if the mouse has been released at all and not necessarily released while on top of this draggable. Well, for that, we can simply do the same thing into our input event, which catches all inputs. So what I could do would be to say, okay, if event.isActionReleased click, and if it's dragging, because otherwise it doesn't make sense to check this, so and is dragging, then we are going to set is dragging to false. And now if I press F6, you'll see that I can drag this, I can run as fast as I can with my mouse, and it still leaves it in place. Okay, now what else should this draggable do? Well, finally, what this should do would be to collide with something. So for example, we might drag this onto an area. So how do we find on which area we have dragged this on? Well, we can simply make a variable and call it var overlapping areas and set this to equal to get overlapping areas. And this is actually going to return all the areas that this has landed on. Now I'm always going to have a single area because I do not care about the other areas. Every draggable is going to interact with a single thing, but you could make some kind of functionality that treats these areas differently. Now, with this area in mind, I'm not going to do anything else here. I'm not going to try to land on the area or anything. I'm simply going to emit a signal to my parent to let it know that I have been dropped. So what I'm going to do is to look at my signal called dropped, and I'm gonna say dropped.emit. And what are we going to emit? Well, first of all, the parent should need some information about me, so I'm just gonna say self, and also it should need an information about the overlapping areas. So it's me who has basically been dropped on these areas. Okay, and finally, if we simply do not land on any area, so if overlapping areas, so or maybe if not overlapping areas, so if there were no overlapping areas, then we simply want to self-destruct. We did not drop on anything, okay, self-destruct, and the content manager will just spawn another draggable. So I'm just gonna call self-destruct, which is just a pretty way of destroying this. It's just calling Q3, but it's playing an animation before. So right now, if I press F6, you'll see that I can drag this, and if I leave it, it self-destructs. Okay, so we have actually defined everything there is to need about the functionality of the decoration components, and we also sent a signal towards the parent content manager, which is going to tell the manager how to treat whatever happened in this component. Now, what's next is to go to our content manager and see how we spawn and manage these components. Okay, now the content manager, as I said, is pretty much just a node 2D under which we are going to instantiate all our draggables. Now, if we look more closely into our code, we'll see that the content manager only does a few things. First of all, it gets some decoration instancing information, which pretty much tells us what kind of sprites is the decoration going to use. So it's going to select, let's say, this bubbles folder, which has this sprites, or the gingerbread folder, or so on. We need to know the decoration count and what is the separation between these decorations. Okay, now the other thing is that we have some properties of these decorations. The first property is just how large they're going to be. And the second property is what the decorations are going to collide with. You see, these decorations can collide with different areas. And we'll later see that number 2 is the area for the tree, number 3 is the area for the tip, and number 4 is the area for the row of gingerbread cookies. So we by default set it to collide with the tree, but our drawer could specify a different value. Okay, so now having this in mind, we just need a way to initialize these draggables. So what I'm going to do is to make an initialize function in which, first of all, I am getting all the textures from the specified folder with load textures from folder. Now this is actually a pretty simple function that I made, which is just the classic walking over a directory, and we can do this with the dir access object. This object allows us to do some operations on a directory, and the first operation that we do is to actually try to open whatever was at this path. Now if we manage to open, we start listing elements from this directory. As long as we can get a next element, so as long as file name is not going to be empty, if that element is not a directory, and if that element ends with a .png, then we are going to build the texture path, which is the folder path / file name, and to this textures array, we are going to append the loaded texture. Now we simply go to the next file, and basically when we finish, we say, okay, finish listing files, and then we return the textures that we have collected. Now, having these textures, what we have to do is to instantiate the draggables or the decorations. So we said that we have a given amount of decorations, so we use I to iterate over the interval defined by 0 and decoration count. Now what happens next is that I just add an offset to the x-axis of our decorations, so global position.x is going to be equal to I multiplied by some separation that I added here. On y, I decided to just leave it like that. It's a bit boring, I know, but it's pretty fine. And the new position is going to be the vector between the position of x and the position of y, which has to be converted to local because here we had global positions. Now for the texture, what we are going to do is to simply select a texture based on the value of I, and we are selecting that texture from our textures from folder array. Now to make sure that we do not go over our array, first of all, we get the size of the array, and if it's larger than 0, then we get an element that is at the position I modulo text number, which sets this position between 0 and the maximum number of elements, basically always picking a correct element. Now, if we set the current texture, we can simply call an instantiate decoration function, which is going to instantiate a decoration. Now, as I said, this is going to be pretty straightforward because we just instantiate our draggable scene, which we have preloaded here at the top. Then we are going to set the position to the position that we defined here for our current element. We are going to set the collision mask to whatever we specified here, and we are going to set the scale of our decoration. Okay, now if we also have a texture, then we say decoration.texture is going to be equal to texture. And if you remember here, we had this texture variable that we used in order to set our sprite texture. Okay, but now if I go back to my content manager, you'll see that what I do is to also connect the dropped signal on our current content manager, because the new decoration that we have created should send a signal to us after it has been dropped somewhere. Now we'll go over what this function does in a moment, but finally what we do is to add the decoration as a child of the content manager. Okay, but pretty much everything has been set except this onDraggable dropped. And if we want to prove to ourselves that everything has been set, let's just set some default decoration folder. And maybe to set it easier, let's say export underscore directory. Okay, if I save it now, you see that I can select the directory. And in here, I'm going to go under assets and let's select stars, why not? And if I select this folder and decoration count set to, I don't know, yeah, maybe 6 is okay. We have it 6 predefined here. If I press now F6, you'll see nothing. Why? Okay, I figured out that we actually never called this initialize function. So now if I'm going to write func ready and actually call temporarily this initialize here, if I save, if I press F6, you'll see that from this stars folder, I collected all the star images and I spawned some draggables depending on which order they had into this array. And again, if I drag this, I can let it go and destroy itself without even interacting with it at all inside our draggable dropped signal. But still, what do we want to do in this signal? Well, first of all, when the draggable is dropped, we want to initialize another draggable at the same position. And this is the place in which I said that I'm going to cheat a little and take the initial position directly from the draggable. So what I'm doing is simply calling instantiate decoration, and in this instantiate decoration I'm going to simply set the position to draggable dot initial position, which was the value that we set before, and the texture to draggable dot texture. Okay, so we want to spawn a draggable which has the same texture as the one we previously dropped. Now if I save and if I press F6, you will see that I can drag this, drop it, and another draggable is going to be spawned. Now we cannot stop this signal here because if you remember, we have to propagate up the signal so that it reaches our main function. Now basically, when do we want to propagate this signal? Well, first of all, the most simple case would be dropping the draggable on empty space, so actually not overlapping any areas. If we don't overlap any areas, then we have no areas to add our draggable to, and we just let the draggable destroy itself. So basically, we only want to do things when we actually have overlapping areas. So I'm just gonna say if overlapping areas, and if we have any overlapping areas, simply emit the signal upwards. And let's call this signal content successfully dropped, because it's not actually this that dropped, it's the content of this that dropped. So the signal is content successfully dropped. So I'm gonna say content successfully dropped dot, I said that too much. Okay, dot emit. And what has been dropped? Well, again, the draggable, and also it has been dropped on what? Well, let's say this time that it has been dropped on overlapping areas of 0, because now we know for sure that we have overlapping areas, so we can select the first overlapping area that we had here. Now, before we move on to the next component, let us first remove our ready function which initializes everything, because the drawer is going to initialize it anyway, and let us see if we implemented this draggable dropped corrected. Do you think you can spot the problem that we have here? Okay, let us pretend that everything else is implemented, because it will make it way easier for you to visualize the problem. If I now press F5, you'll see that I have my project here with the components that we're going to look over soon enough. And at the first glance, you would say that this works fine, because I can drag this bubble and you see I put it outside and it responds just the same as this one and so on. And the same with the stars, the same with the gingerbread people and cat. And yeah, it's perfectly fine. It also works if I put it on my Christmas tree. Though, there is a small issue. If I now decide to, let's say, move this bubble to another place, here, you see that it spawned another one. And if I move it again, it spawned another one, and it spawns another one, and so on. Now, why is this happening? Well, this is happening because the dropped signal is still connected to our content manager. And because it is, whenever our bubble gets dropped, well, it just spawns another decoration on top of whatever was there. Now, there are some solutions to this. We could, for example, check if, let's say, there is nothing at that position and simply spawn only if there is nothing and not spawn if there is something. But an even simpler solution, and the solution that to me at least makes sense, would be to simply disconnect this signal from the onDraggable dropped function. So basically, not the decoration, but in this function it's called a draggable. I'm just going to say draggable dot disconnect the dropped signal from onDraggable dropped. Because if we disconnect it, then it doesn't matter if the draggable gets moved anywhere, because it will not send a signal to our content manager. So you can see I move it as much as I want and nothing happens. But again, the newly spawned draggable acts as normal. Okay, now we pretty much covered our content managers. And brace with me, because we will only have to cover just a few more things before our whole application is finished. Good. Now, the next thing is obviously to take this signal that we sent with the content managers to the drawer and pass it further to our main function, and also to implement the drawer movement functionality. Now, if you take a look at the drawer, you'll see that it's very simple, because all we have is what we already know. We have an area 2D, and we have a region that defines that area around the drawer's handle. Now, whenever we click on this handle, obviously we want to move from left to right, and we also have this sprite, and we have the content, which is the content manager node we have covered previously, and this is set to be here so that whenever the decorations get spawned, they get spawned from this point on towards the right or towards the end of our drawer. Now, if we go to the code, you'll see that almost all the code is here. And why is it here? Well, because it's almost the same code as we've had before. And what do I mean by that? Well, first of all, the only thing that we set up on top of what we have previously said is these drawer settings, which set a left and a right limit to what's basically the maximum left limit at which the drawer can be drawn or pulled, and the right limit, it's basically the closing limit of the drawer. Now, on top of that, we have these settings, which, if you remember, are precisely the decoration settings that we are sending to our content. Now, how do we set this up? Well, just as before, all these values are going to be taken and passed down to the content child, which, basically is just content.decorationsprite folder equals decoration sprite folder, and so on, until finally we also connect this connect successfully dropped, so the signal that is going to be emitted whenever Draggable is dropped, and we connect it to this function. Now, what happens in this function? Well, as we said before, we just want to pass this value to our main function so that the main function does its thing and assigns this to an area. Okay, so what I'm gonna do is take this successfully dropped signal and emit it with the parameters Draggable and area. And actually, that's all we have to do for that. Now, moving further down, let's actually make our drawer move. First of all, our drawer is pretty much acting in the same way as a Draggable, because when we click on the handle, we want the drawer to follow our mouse, and when we release the click, we want the drawer to no longer follow our mouse. To do that, we need obviously an isDragging variable. So now, just as before, whenever a click is pressed on the region that we defined for the handle, then we are going to set isDragging to true. Otherwise, if the click is released, even though we're not on the handle, that's why I put this into the input event, we are going to set isDragging to false. Now you might ask yourself the following question. Why do we set drag start and velocity? Well, let's get the most simple thing out of the way. First of all, I set the velocity to 0 because I want to be able to catch my handle. I don't want to have the handle run away from my mouse, so whenever I click on the handle, I want the handle to stay in place. Now, the second thing here is more interesting because I didn't want to implement the same type of movement as I did before with my Draggable, which pretty much just lerped the global position towards the global mouse position. What I wanted to do instead was to simulate some kind of acceleration, so I keep track of where I start dragging and I basically check how much the mouse have moved from that position. Because if the mouse moved just a little, it means that we are not really accelerating, so if it moved like this, but if the mouse moved like this in a single frame, then of course the acceleration should grow. So what I'm doing is when it is dragging, just as before, I'm getting the mouse position and I calculate a drag delta, and delta comes basically from a difference of drag between the current position of the mouse and the drag start. Now, the velocity.x is going to clamp this drag delta between a max velocity on the negative side and on the positive side, and we are going to set the drag start to the current mouse position. Now, of course, since we're talking about a drawer, it's only going to move left and right and not up and down. And that is why the drag delta calculated here and the velocity only takes the x coordinate into account. Now, that's why when I change the position, I also change the x coordinate of the position. But notice that this time, I'm not only setting the position to whatever value I got, I'm adding to this position the velocity that I got from this difference of drag acceleration, let's call it. Of course, now finally what I do is to clamp the position between the left and the right limit that I have defined here above. Now if I move to my drawer scene and press F6, you will see that I am able to move this drawer, and you see that it keeps going depending on how hard I started moving. If I move slowly, it goes slowly, and if I move harder, it goes faster. Or yeah, it just follows the position of the mouse if I keep holding. Okay, but yeah, that's it on the drawer. I'm sorry, I like playing with it. Okay, next one. If we now go to our main scene, you will see that we are at the top of our tree, which means that we are going to keep track here of the drawers that we previously mentioned and of the tree and the areas that define it. And yeah, now if we take a look at the actual structure of main, you'll see that we have a node for the drawers, which has 3 drawers that we instantiated with some different parameters, and also a node which contains the sprite of the tree and 3 different areas that we are going to use in order to give different behavior to our decorations. Okay, so now we can go to the actual code, and all we have to do is to find some way to connect whatever draggable has been dropped from these drawers to a corresponding area 2D. And now, the way in which we connect the drawers to an area 2D is actually up to us, because we now have both access to the drawers and to the area 2Ds. We could reference them in any way we wanted in order to simply call a function on the area 2Ds so that they can in some way attach that draggable to themselves. Now you'll see that in my case it's going to be much simpler, because if you remember, each draggable is going to interact only with the elements on the layer 2 for the tree, on the layer 3 for the tip, and on the layer 4 for the row. We could have, of course, added to our drawers a new parameter to which we would have set the corresponding areas so that the draggables only landed on those areas, but since we have the decoration collision parameter, why not make use of it and do everything much simpler? Okay, so what I'm going to do is first of all to drag and drop our drawers node so that we can iterate through each drawer so that we connect the signal that was emitted by the dropped draggables. So what I'm doing is for child in drawers.getChildren, I'm going to first of all check if the child is a drawer. So if child is drawer, then if it is a drawer, it for sure has the successfully dropped signal. So what I can do is connect that signal to a function here in my main. So I'm just gonna say child.connect, and what I said, successfully dropped, and we connect it to, I don't know, on successfully dropped. Can't believe I wrote that correctly immediately. Now, of course, we don't have the on successfully dropped function, but what I'm gonna do, I'm gonna make it. So func on successfully dropped. And what are we going to drop? Well, we are dropping a decoration, which is a draggable, and we are dropping it to an area, which is an area 2D. Now, from here, we have a small issue. We want to have different types of areas which act in different ways, but we want to call them in the same way. Now, how are we going to do that? Well, what we could do would be to make an abstract class. And how is that going to work? Well, I have here a drop zone class that I created, and this is basically just something that extends an area 2D, and this has the class name set to drop zone. Now, I'm calling this an abstract class because it doesn't have an actual implementation here. It just has a function that is defined as add decoration, which takes as a parameter a decoration that's a draggable. Now, how this is going to help us is that whenever we extend this drop zone with, let's say, the Christmas tree area 2D or the tree tip area 2D, we could add a new implementation to this add decoration function, but the interface of this is still the addDecoration function. So whenever we are in our main function, we simply check if the area is, so if area is a drop zone, we are simply going to call area.addDecoration because we know that a drop zone can add a decoration. We do not care how it does it, we know that it can do that. Now at this point, we finished doing everything in main. All that remains is to create whatever areas we want with whatever behavior we want, and all the draggables will follow that behavior when dropping on those areas. So let's look at the simplest example in which we just want to drag a bubble and place it at the spot at which we left the mouse button. In order to do that, we first have to define the region of this area. Now, I want to be able to place the bubbles at any point in my tree, so what I'm going to do is to simply select the tree sprite, and if I click here, I can create a collision polygon to this sibling, and yeah, this could be, maybe let's simplify it more, let's make it 10 so that it's not so complex. I made a simpler shape, and now I create a polygon 2D, and I can simply draw this collision polygon under the Christmas tree, and you see that my area is now functional. Okay, now if we go to the code of our area 2D, what we have to do is to first of all, just as we said before, extend the drop zone behavior. So I'm just going to say extends drop zone. And what does a drop zone do? Well, a drop zone adds a decoration. So I'm going to simply write func add decoration of decoration. That's a draggable. And this time, instead of simply passing, we are going to add some implementation. And the simplest implementation that we can do is to simply reparent the decoration to the current content node. So let me just drag this content node. I'm going to have it here. And what I will do is to simply say decoration.reparent to content. Okay, now to test this, I'm going to press F5 and I will also go to the remote view so that we can see what nodes get added to our content. If I'm here, I can simply drag and drop this bubble and put it, let's say, somewhere on the area, and you see that a new draggable has been added here. And I could do the same with as many bubbles as I wanted. Now, of course, if I'm going to take a bubble out, it's going to get removed. So yeah, simply it works perfectly fine. Now, what if we wanted, let's say, to create a snappable region? Let's say that we wanted to have a region on which if we landed with a decoration, the decoration simply moves towards the top of our tree, as you saw before in the example with the star. Well, again, what we could do would be to create this new tree tip area 2D, which again has the same polygon as this one, because no matter where we land on the tree, we want the star to go up, and also has this content node. Now, on top of this content node, we also want to have a marker, which if I show this very quickly, you'll see that points exactly at the top of the tree. Good, so now if we go to the code, just as before, we extend the drop zone and we get a reference of our marker and of the content. Now, what do we want to do this time? Well, first of all, just as before, we want to reparent the draggable to our new area. So what I'm going to do is to say decoration.reparent, and we reparent it to the content. Okay, now after we reparent it, we want it to go towards the marker 2D position. And that's going to be very easy because we are going to simply use a tween. So what I'm going to do is to simply write get tree dot create tween, and I want to just tween a property, so I'm just gonna say tween property. And which property do I want to tween? Well, of course, I want to take the decoration's position and move it towards the marker to this position. So the object that I'm referring to is going to be decoration, and the property that I want to move is going to be the position. And where do I want to take this position? Well, I want to take it to the marker to this position. So marker to d dot position. Now, how much do I want to wait for this animation to finish? It's going to be like 0.3 seconds, why not? And here I could add some easing just to make the animation prettier. So I could set ease to, I don't know, ease in. And I could also set transition mode with set trans. And here I could have, let's say, a cubic transition. Okay, now we just have to make sure that the corresponding drawer is configured properly. So as you can see, the tree tip is sitting on the third layer, which is the layer called tip. And the second drawer is going to make all decorations interact only with the tip layer. Having this means that our decoration is only going to interact with this area and not with the Christmas tree area. So it's not going to call both functions for both areas at the same time. So now if I run this, you'll see that what happens is that if I drag this here and place it, it snaps to the top of the tree. Now, of course, if I put another star, the previous star doesn't get removed, but that can be easily fixed because all we have to do is to simply get the children of this content. So for child in content.get children, we are simply going to check if the child is a draggable. So if child is draggable, and if it is a draggable, then we can call its self-destruct function. So I'm going to say child.self-destruct. Now, if we press F5, we'll see that the behavior pretty much works as before, but if we place another star, it's going to replace the previous star. Now for last, I wanted to implement some behavior that acts a bit more complex. I want to have this gingerbread, people and cat be placed in some predefined zones. And what I want to happen is when I put a gingerbread on the tree, I want it to snap to the closest position. So if, let's say, the region is here, I place the gingerbread and it snaps to this position. If I put one here to the right, I expect it to go towards the rightmost point, and if I place it here, for example, it goes in between. Now also what I want is to be able to place something on top of another gingerbread. And if I do that, you'll see that the previous gingerbread is going to go to another place. So let's just put this here, and you see that this little girl gingerbread moved towards the left. If I put another one, the places are going to get filled up. Now, what do I want to happen when I put another gingerbread? Well, of course, I just want to remove whatever was there so that I can put the new one in place. So let's just take this cat and put it here. You see that the man basically left and now we only have the cat. Okay, so now that we are inside the code, what I want you to understand and what I think is very important is the fact that all that we have to do in order to implement this new complex behavior is to simply modify how this addDecoration function behaves. Because we do not care about how the draggable acts, we do not care about the drawers, we do not care about any other component as they are working on their own accord, and we only have to figure out how do we move around the draggable that we received from those components and let everything work it out itself. So in this case, what I have is, first of all, 5 markers. Maybe I'm going to show them. You see here I have 5 predefined spots in which I want my gingerbread to land. Now if I go to my script, in the addDecoration, just as before, I'm going to reparent the content. Now of course, if you remember, I also said that I want to be able to move the gingerbread people from one marker to another. So basically, once I draw them into the area 2D, I want them to have this extra behavior. For that, what I did was to connect the dropped signal again, but this time to a new function that I added here in line. And by the way, whenever we add a function in line, it's basically just as if we would have defined it here, but since it's in line, it's called a lambda function. Now, because if you remember, the dropped signal had been emitted with 2 parameters, we have to also make this function take 2 parameters. However, in our case, we don't really care about the second parameter, so we are just going to ignore it. So just imagine that we have a function here that only depends on the thing that has been dragged. So what do we want this to do? Whenever a gingerbread person is moved from one place to another, we want the gingerbread to basically say, hey, I have freed this place and I also want to find the closest place that I can move to. And what this does is basically to simply call a function called reset marker status and call a function called find a place. Now the reset marker status goes through each marker status, and if it finds the one corresponding to the decoration, it sets it to null. And maybe more interesting, the find a place function simply takes the decoration and finds the closest marker. So what happens here? Now this get closest marker does exactly what you'd expect. It takes this decoration and calculates the distance to all markers. As you can see, we iterate here through all the markers. Now this distance is going to be stored into a minimum distance variable, and if this minimum distance has been changed, then we are also going to change the closest marker. And in the end, we are just going to remain with the closest marker. Now finally, all we have to do is to check if that place is not occupied by some other gingerbread. And to do that, we simply check if marker status of the closest marker that we just found is different from null. If it is different from null, it means that it has an occupant. So we just take a reference of that occupant, and the occupant is supposed to find an empty marker. Now, find an empty marker simply again goes through all the markers, and if it finds something that's null, it's pretty much going to say, okay, then I will go to that marker. So after I find this empty marker, actually if I found it, I am going to simply make the occupant move to that marker. How does it move? Again, it's just some pretty basic movement made by a tween property, and also it's setting the marker to be occupied by this node that has just been moved. Okay, and finally, if for some reason we did not find any empty marker, then we are going to simply self-destruct this occupant. Now, if this occupant for some reason was not a draggable, of course we shouldn't be here, so I'm just printing you shouldn't be here. Now, finally, after we moved the occupant away, what we do is to move the decoration to the closest marker that we found. And yeah, that's pretty much all the functionality that we have. Now, I really hope that you clicked on this video because you wanted to learn a thing or two about dragging and dropping, and that I have fooled you into learning actual game design in order to achieve this dragging and dropping in a more complex environment. Now, before we finalize, I wanted to let you know that I'm going to be posting these assets for free on itch.io so that you can use them in any way you want, and I will also be posting sometime later the full game so that you can decorate your own Christmas tree. Thanks again for watching, thanks to my Ko-fi supporter, and happy holidays everyone! See ya!